In this video, we're going to look at some fundamental facts about data and how it's stored and worked with inside your computer. The first thing to realize is that all data values are stored in the computer as binary numbers, meaning they're essentially long sequences of zeros and ones. So for example, we have 16 zeros and ones here, and that might represent a single character in a piece of text. And everything, whether it be a number or text or video or images, it's all stored as binary numbers. Each individual 0 or 1 is referred to as a single bit, which is short for binary digit. And when you put those bits together, you get larger units. So 8 bits give you a byte. So here we have one example of a byte. It has 8 bits. A kilobyte is approximately 1,000 bytes. Although it turns out everything in computer science is a power of 2, so more precisely a kilobyte is 2 to the 10th bytes, which is a little more than 1,000. It's 1024 bytes. Similarly, a megabyte is roughly 1,000,000, but it's more precisely 2 to the 20th bytes, which is a little more than 1,000,000. And a gigabyte is approximately 1,000,000,000 bytes. More precisely, it's 2 to the 30th bytes, which is a little more than 1,000,000,000. Now, when it comes to processing data, at the heart of the computer is the central processing unit, or the CPU, and that's where data gets worked on. In particular, there are pieces of hardware for taking our binary data and doing stuff with it, like taking two binary numbers and adding them together, or shifting the bits in a given binary number. There's all these different fundamental pieces of hardware in the CPU. However, there isn't much room in the CPU to actually store data. There's only a small amount of storage so that it can hold the values that it's currently processing. But it can't keep stuff there for very long. And as a result, in addition to the CPU, the other key piece that is inside our computer is the memory. And that's where we can store a larger amount of data, both the programs that we're currently using and the data that is being used by those programs. And when the CPU needs some data, it can read values from memory into the CPU. It can then operate on them, and then the results can get stored back to memory. So there's this back and forth that happens where data values are read from memory into the CPU, and then when you have the results, those results can get written back to memory. Now, one nice thing about memory is you can access stuff in it. You can access the data in your memory in a very short amount of time, on the order of nanoseconds. And every nanosecond is 10 to the negative 9 seconds. So a very, very small amount of time. However, memory is expensive, so we can't have unlimited amounts of memory. Now, we have way more memory now than we used to, but there's still a practical limit because it's so expensive. And then the other real shortcoming of memory is if you turn your machine off, everything in the memory goes away, so it's not permanent. As a result, we need some form of secondary storage. There's lots of different ways of doing this, and here you can store stuff more permanently. The most common type of secondary storage is a hard disk or a hard drive. I'm picturing it here as this cylinder. You can think of it as being separate from the other two components. And here again, we're reading stuff back and forth. So values get read from disk into memory. They can then go from memory to the CPU, and then we can also go back again. The results of the CPU operations go to memory, and then later on they can go to disk. And the benefit here is that disks are relatively inexpensive, and their contents are not lost when the power goes off. So that's a real benefit of using a hard drive, is you can retain your programs and your data even after you turn the machine off. Disks do have a corresponding disadvantage, which is long access times, meaning it's relatively expensive, relatively costly when it comes to how much time is needed to read something from the disk or to write something to the disk. And it turns out that data is transferred in relatively large units called blocks. And blocks are typically something like 4 kilobytes or 8 kilobytes, or maybe even larger. So you're reading in a pretty large chunk when you get something from the disk. and it can take on the order of 10 milliseconds, so 10 to the negative 3 seconds, to read one block. And if you remember from memory, it was on the order of nanoseconds, 10 to the negative 9, and here we're actually saying 10 to the negative 3. So it's taking much longer to do this. In the time that it takes to read one block from disk, the CPU could be doing millions of operations. And so you potentially end up slowing your program down if you have to read from disk a lot. If you've ever had a program open on your machine and then done some other thing for a while, maybe gone to a different program, worked with it, and then you switch back to the original program, you may notice a delay, and that's because the computer has to read that program back in from the disk, and it can take a while for it to do that. So as a result, when we're dealing with large collections of data, we want to try to minimize the number of times that we have to access the disk. And that's one of the key roles of a DBMS, a database management system. And we'll start to look at that role and other key roles of database systems in our next lecture.